So suppose that I'm watching a video that relates to topic 1B, and this is the problem that's being done, and I'd like to take notes on it. So as I watch the video, I might take notes in this big area here with the lines in it on the step-by-step process of how it's done. So maybe I'll start by just writing 1/3 plus 2/5 times 1/6, the same as the original question. And then as I'm watching the video, the person in the video will probably say, what do we do first if I'm going to evaluate this expression? What do you say?
Times the 5 and the 6.
So you want to multiply the 5 and the 6. First of all, why multiply? Why is that a good choice for what to do first?
Because of, I remember as, please excuse my dear Aunt Sally.
Please excuse my dear Aunt Sally. There are a number of different acronyms, sentences to place to this, but yeah, that's one of the more popular ones. Pemdas, also known as the order of operations. And what do these stand for?
Parentheses, exponents, multiplication, division, add and subtract.
Parentheses, exponents, multiplication and division, and addition and subtraction. And so you're looking at this expression. You're not seeing any parentheses. You're not seeing any exponents. But sure enough, we do have some multiplication happening. And so that should be the first thing that we would do. We need to multiply these two fractions before we do this addition that happens in the front, right? So maybe I'll write that in the margin. First, multiply. So the margin over here on the left is a place for you to record those insights in your own words as you come across them. You might do them as you go. You might do them afterwards, after you do all of the work, then go back and look at it and kind of give your thought process along the side. But this will help you to understand later on why you chose to do the steps that you chose to do along the way of solving this problem. So I'm going to record that little note over there in the left-hand column of my notes. Okay, so then the question is, how do we multiply two fractions? How am I going to multiply 2/5 times 1/6? You had a way to get us started. What did you do?
Well, what I did was you could times both numbers. So you do the 5 times 6, and then you do the 2 times 1.
Okay, great. So to multiply two fractions, we multiply straight across the denominators, 5 times 6. And 5 times 6 is going to give us 30. And multiply straight across the numerators, 2 times 1. 2. Great. So when you multiply fractions, multiply straight across. I'm going to record again that little insight in the margin. Straight across to multiply fractions. So you kind of get a feel for how this note-taking method works. You do a step over on the right-hand side, and then you record some explanation for why you did that step on the left-hand side. And in this case, after that first multiplication step, I end up with 2/30 as my second fraction. Okay, so we took care of the multiplication step. Great. What do you want to do next? Yeah.
Find a common denominator.
Great. How do we know we need a common denominator to keep going here?
Because when you add fractions, you have to have the same a common denominator.
Great. So now we want to add fractions, so we need a common denominator. We didn't need a common denominator to multiply fractions, but we do need one to add or subtract. Okay, so what common denominator can we choose for this pair of fractions?
30.
30 is a good choice, right? Well, how do you know 30 is workable? Why is 30 okay?
Well, it's just times 10, so you'll get a nice even number.
What did you multiply by 10?
1 and 3.
Okay, right. So we know that 30 is a multiple of 3, because if I multiply it by 10, I get 30. 30 is also a multiple of 30 if I multiply by what? 1. Now, that's what to do with the denominators to make them common. What do we have to do with the numerators? Exactly. Whatever you multiply one part of a fraction by, the other part must also be multiplied by in order to keep the value of that fraction the same. So, on the right side, I'm going to multiply my 2 by 1, and not much changes. But on the left side, my 1/3, I'm going to multiply 1 by, what do I multiply the 1 by? Yeah, the 10, exactly. Whatever I multiply the denominator by, I also have to multiply the numerator by. So I multiplied the denominator by 10. We decided to go from 3 to 30. 30 divided by 3 is 10. And therefore, likewise upstairs, I'll multiply my numerator by 10. And now I have a pair of fractions that have common denominator as one another. Great. So now that we've done that, how do we complete the addition? Yeah, add across. Which part of the fraction? Yeah. So I'm going to add across the numerator. What do I do with the denominator? Keep it the same. So actually, denominators never get added or subtracted. They only get kept, preserved. So I'm going to keep the denominator the same, namely 30. I'm going to add across the numerators, 10 plus 2. It's going to give me 12. And now I've sort of completed all of the work that the order of operations told me to do. I dealt with parentheses and exponents by observing we didn't have any. We dealt with multiplication by multiplying the pair of fractions that you saw here at the end. There was no division to do. And then we dealt with the addition and subtraction. Are we done? Why are you shaking your head? What do we still have to do? Simplify. How do I simplify this fraction 12 over 30? Yeah.
2/5.
How do you know it's 2/5?
Divide by 6.
Great. So you looked at these two numbers, the numerator and the denominator, and you observed that 30 and 12 both have a common factor of 6. And in fact, that's the largest common factor that we can find between 12 and 30. And for the same reason that we were able to multiply the numerator and denominator by the same thing to give us the same fraction, we can also divide the numerator and denominator by the same thing to give us the same fraction. If I divide by 6 on the top and also on the bottom, then the leftover is going to give me on the top 2 and on the bottom 5. And then that fraction has been reduced into its lowest terms. So now we've taken notes on this problem. Right? We did all of the work in the main area over here on the right. We recorded some insights, why we chose to do the steps that we chose to do on the left-hand side, which is great. Now at the end of the problem, this is the perhaps most underrated step in the process. This is really going to help. You can do this at any point, but it's best to do it, I think, after you've worked through the whole thing. Look over the whole problem, maybe look at it step by step, and ask yourself, where am I going to screw this up? When these problems come along on the exam, where am I most likely to forget something, or where am I most likely to make a choice that's not the greatest choice? Well, what do you think? Looking at this process, where are you going to screw this up? Yeah.
You have to multiply the two fractions in the beginning.
Okay. How would you screw up that step, do you think?
I'd probably mix it up with like dividing, how like you could cross multiply.
That is an incredibly common point of confusion. So, if looking through this process, that's something you want to make sure to remember, record that down here in the summary, something that you want to remember. Remember, fractions multiply straight across, for example. To be fair, that's probably an observation. Well, that might be an observation you would have made back here as well, but probably not. This is probably the right place for it. Anyone else see something in this problem that you feel like would be the most likely place for you to go awry? Yeah.
I was just wondering, would it work the same if you had reduced 2/3 in like the second step to 1/15?
Absolutely. Great question. So her question is, we took this fraction 2 over 30 and we just took it as it is. And we went forward and we found a common denominator of 30 and did it. But your point is that we could have reduced this fraction right here. Instead of 2 over 30, we could have reduced that by dividing the numerator and denominator by 2 and making it 1 over 15. Then the common denominator we chose would probably have been 15 instead of 30. And at the end of the day, we would have gotten the same answer. It absolutely does work the same. So whether and when you simplify a fraction is more or less up to you, as long as at the end of the day, your final answer is simplified completely. If you want to do some simplifying along the way, you're welcome to do that. It won't screw you up. In fact, it might make your life a little easier. Any other insights about this process that you want to hold on to for your own sake, to record at the bottom of the page?
Real quick.
Yeah.
So The only part I always struggle with these is the common denominator. So the common denominator is always going to be the highest number.
The highest
So
number.
30 would be the common denominator, whereas 15 would have been the common denominator.
That, let me sit with that question for a moment. So his question is, in this example, our common denominator just turned out to be the larger of the two denominators. Is that always going to be the case? Can you think of an example of a time when that might not happen?
You could have like 1/10 and 2/20.
Actually, I think their 20 is still going to be a common denominator for
Couldn't
us.
you just divide 2/20 by?
Well, maybe let me just take your example and modify it a little bit. Okay. What if I were trying to add 1/10 plus 2/7? What's an example of a common denominator we could use here? Back half of the room. Here, so.
I mean, 7 is the larger.
Seven.
Oh, no, wait a minute, I'm sorry.
Yeah, we need a. So what do we need? We need a number which we can multiply 10 by and get that number, but also multiply 7 by and get that same number.
70?
Say again?
70?
70. Where'd 70 come from? How'd you get that?
We just multiply them together.
You know, I make this recommendation until I'm blue in the face, because this is, honestly, when I add fractions, this is my path of least resistance to doing it. You can always get away for common denominators with just multiplying the two denominators together. When the denominators don't have any common factors with one another, this is the only way. Well, not the only way, but the best way. When they have some common factors, so 30 and 3 happen to share a 3 in common. So 3 already went into 30, which is why we got away with just using 30. But 10 and 7, they don't share any common factors. 10 is made up of 2's and 5's. 7 is made up of, well, just 7. So the only option that we have here would have been to multiply 10 times 7 and go up to 70. We could have picked even bigger common multiples, like 700, but it's not really worth it. The reason that I like doing this, by the way, is that finding the numerators is a little more convenient. So if I want to know what numerator 1/10 is going to get when it goes up to a 70 denominator, how would I get that? Multiply by 7. How do we know 7 was the right thing to multiply by? Yeah. So the observation was that we multiplied by 7 in the denominator, so we should also multiply by 7 in the numerator. But here's my little mnemonic trick, my little gag. Where did this 7 come from? It came from this other denominator. So another way to see where these numerators come from, when you multiply the denominators together, is just to see it as the result of multiplying the 1, the numerator of the first fraction, by 7, the denominator from the second. And 1 times 7 is then going to give me the 7, which is the numerator of that new fraction. Likewise, for 2 over 7, what's my numerator going to be when I put it over 70? 20, and why is it 20?
You're multiplying that by 10.
Multiplying it by 10, and that 10 came from the other denominator. So these cross products give us a nifty little way, a quick and dirty little way, to get two fractions onto a common denominator by first multiplying the denominators together and then taking the cross products of the numerator with denominator to balance out the numerators. So this I like because it involves a little bit less cognitive demand. I don't have to think as hard to find common denominators for fractions when I just go straight across the denominators and then take the cross products of the numerators. That will always work. If we did that here, we would end up with a common denominator of 90, which is okay. That's fine. We would have a little bit more work to do at the end of the problem to simplify, but we would still get through it. So if you feel like the common denominator is the step that you might mess up when you look at this later, you might decide to write in here something like, can always multiply denominators together to find a common. Multiply denominators together. So this was kind of a meta lesson. It was an introduction to the topic you're going to work on in your groups in just a moment, and it's also a suggestion on how to structure your notes. And when you receive your workbook in a couple of days, you're going to have one of these notes pages for each of the 30 gold topics in the course. And as you go along and work in ALEX on these topics, my strong recommendation is that you build a notes page like these for each of the 30 gold topics. Because when it comes time to look back at all these topics for the exam, you'll have a nicely worked out example. You'll have your own words about what are the step-by-steps, why are you making certain choices, and then at the bottom of the pages you'll also have a little summary. What's most important that I need to know about this topic to make sure that I can succeed on it on the exam.